Hello everyone, welcome back. Today we are going to talk about for loops. So there are different types of loops that we can go over a certain data type, and for example lists, strings, etc. Iterate over them. However, today we are focusing on for loops specifically. But in this section, we are going to discuss different for loops as well. So, for example, imagine that we would like to print a few numbers and it would be very hard to do it easily. Like, for example, I could say see out number one and del. So I want to write, like, imagine that I would like to print number 1 to 5. So I need to do it 5 times. So I modify this. I put 5 here, I put 4 here. So now I need to print this one. So let's compile and see. So yeah, here you see when I want to print 5 numbers, I need to write it down 5 times. Okay, but for 5 times it may be still okay. But what if it's 500 times? It would be very hard to, track the changes, to modify everything, and at least copy paste it. Even copy pasting it for 500 times, it's not easy job. So there are other ways to do it, and in programming, you something that can give us the best and most efficient way of coding. So in order to do that, we need to use loops generally, and today I'm going to tell you how to use for loops to do that. So imagine from number 0 to number 4. To do that, we come up with a for function. We have parentheses within which there are three main components in this parenthesis. So in the first component, we initialize integer as to be whatever the initial number of the loop would like to be. So here in our case, we integer named I that starts from 0. Then we have semicolon separating the first part from the second. We have this I until it reads like this I until it is smaller than 5, not smaller equal than 5, only smaller than 5. Then semicolon saying I plus plus, and I plus plus means that the increment value of I. I'm going to discuss this in a few seconds. So for these are the three components of a for loop in parentheses, and then we start the loop actually as of here. So as of here, we start going through the loop saying that see out I, we print I, so we understand the value of I. It's a printing in the terminal, so it makes more, it increases the readability of the code, and then we print the actual value of the I. But how does it work? Let's see. So first we start from I equals 0. When we start from I equals 0, we enter this loop, we mention I semicolon, then we print the value 0. Then after that, we increase one time the value I. So initially we entered the loop with the I equals 0. We printed the value 0 using this line. And when everything is finished here, it goes back again into this, but because we have incremental value of I is now equal 1, and then with the value 1 it again enters this loop and prints 1 for us here. It iterates until it reaches to this condition. So until it is smaller than 5. So it iterates until it is 4. When it's 4, it breaks and we exit the loop. So let's try and see how it works. So now we're compiling. Okay. So here, as you see, it starts with the value 0. It prints I semicolon 1 space 0. Then it goes up again and enters the loop with value 1. It prints I semicolon, I colon space 1, and then it is incremented again, and it does this iteratively until I reaches 4. When I reaches 4, it enters one more time to the loop saying that cout I colon space print 4, and then when it incremented to the value of 5, it does not satisfy the second part of our for loop, so it does not enter again and it finishes the loop. So this is how we can print something like 5 times. Even if we want, we can say like instead of 5 we can put like 20. So whatever the number that we would like, we just put it here and it will just go for it. Let's see. Yeah. So here it starts from 0 to 19. And if we want to print number 20 as well, we can say smaller equal 20. And instead we could say, for example, let's start from 1 this time. So let's see. Okay, great. So we started from 1 and we're printing until 20. So generally, this is one of the most efficient way of printing iteratively instead of just printing everything manually. And in next lectures, we're going to solve some exercises and do some coding exercises to understand it better. So generally, the important thing is that we write the for, we have parentheses within which 3 parts needs to be filled, and then we enter the loop. Hello everyone, welcome to another session. Today we are going to do some coding exercises using for loops. We are going to write a program that prints even numbers from 1 to 10. To do that, we start right away with the for loop. So we start right away with the for loop and we open the parentheses. And here there are 3 parts to respect. The first one, we initialize one, for example, here integer value equals 1, and we set the upper bound for our integer value here because we want to start from 1 and go up to 10. We say smaller equal 10, and we have the incremental value saying that okay, first 1, then increase it 1 time, then increase it another time. So we use incremental values for that. When we finish 3 parts of the for loop condition, in the parentheses, we enter the for loop actually. Here, because we only would like to print the even numbers, we write one if condition here. So we say if this I is divided by 2 and its remainder equals 0, then cout I. Otherwise, we don't want it. So else we don't write it because we don't want to print anything in the loop because it is going to be printed for those that don't have the remainder equal to 0. So let's print this one and see how it works. Yeah. So it starts from 1. 1 comes here and 1 is divided by 2. Its remainder equals 0. No, so it does not do anything. And then it goes and comes back with 2. 2 divided by 2, its remainder equals 0. Then 2 is printed, and then 3 comes here. And when 3 comes here, 3 divided by 2, its remainder is not 0. And then it is doing nothing and it's printing nothing. And it goes until it reaches the last number. So iteratively it goes up. And here we could, like, for example, we could write something like else, and then here see out I, like this part here. So here, if I do this, it is going to print 1, 3, 5, because 1, 3, 5, 7, 9, basically all the odd numbers, because odd numbers are not going to pass this loop. They're not going to pass this condition, the first condition. They're going to be in the second condition. So let's compile this one, see how it works. Yeah, so it is printing everything now, and it's hard to distinguish the result. This is why here we avoid using else condition. We just want the ones that are having the remainder equals to 0 to be printed. And if we wanted to, for example, print the numbers that are odd, we could write like this. So if I divided by 2, its remainder does not equal 0. This is going to print us all the odd numbers. So let's try. So it's compiling. Okay, great. So here, for example, I is divided by 2, its remainder does not equal 0, then it is printed. Then for second, for number 2, I gets the value equals 2. It enters, 2 is divided by 2, its remainder equals 0 actually, and it does not enter this loop now. And then it prints nothing. Then I is incremented one more time. Now its value is 3. 3 divided by 2, its remainder does not equal 0. Then it enters the if condition and it prints the value. So this is how it works, and generally we can play with it, like if we want to print all the odd numbers between 1 and 100. So it's easy to do it, but manually doing that, it takes a lot of time. So here we see that, yeah, it is printing almost, not almost, but all the odd numbers that are between 1 and 100. So this is one example, very small example, very easy example of how important the for loops are. However, we will see in other levels like intermediate and advanced level that we use these loops very frequently to do very advanced tasks. For example, if you want to find a maximum, the maximum number in a list of numbers. So we do iteratively, we go through all the elements of that list, for example, and then we write some coding there to find the maximum number in a list, for example, or the minimum number, and then we want to do some mathematical operations for that maximum number, etc. So these are very useful, especially if we are going through a lot of data, a list with a lot of inputs, for example, a lot of elements. So imagine that there are like 1000 elements in one list, and you would like to find the maximum number. Manually doing that, it would be very hard, and it takes a lot of time, it increases the error, etc. But doing programming, this is why we are programming. In fact, it can give us the result very fast. Hello everyone, welcome back. In this session, we are going to do another coding exercises. Here we are writing a program that calculates the sum of numbers from 1 to 5. So to do that, we can do it manually, which is the hard way. The easy way is to use for loops. So we initialize sum as to be 0. Then we start a for loop right away. And it has three parts, as you know. So because we are calculating the sum of numbers from 1 to 5, it starts with 1 and its upper bound is 5, and it is incrementing one step at a time. So and since sum equals 0, it is initialized to be 0. Here we have 0 equal 0 plus 1 in the first iteration. So I equals 1. So 1 is assigned to sum. Then it goes up again, I equals 2, and it enters the loop again. So I equals 2 here, and plus sum was 1 from the previous iteration. And the sum of these two will be 3, and 3 is assigned to sum now. So it goes until I equals 5. When it equals 5, it enters for the last time. It does some calculation here, and then the loop is finished. And the final value of sum is printed here. So also I put one line here so we can iteratively see the increase in the value of sum. So let's see how it works. Okay, so as I mentioned here, the first one is sum is 0 and I is 1, so 1 is assigned to sum. Then I is 2, sum is 1, they are 3, and 3 is assigned to sum for the second round. For the third round, it will be 6. For the fourth round, it is 10. And for the last round, it is 15. The last round is stored in the sum for the final number because we are not going to enter the loop anymore. And then we print the value of sum here. So one of the ways to do some of these calculation is using for loops to make it easier. It is always possible to do everything manually, but we're coding to, increase the speed and have more efficiency, etc. So one point here is that now we are saying sum equals sum plus I. So even for this, we could write our code even more simpler and more efficient. So writing it like this, sum plus equal I is exactly like writing sum equals sum plus I. So we could use either way. So let's try uh, this one and see if there is any difference or not. So there shouldn't be. Yes, so as you see, the results are the same. So the results are the same, and it's only the matter of how you would like to code. Usually in advanced programmers are using this method because it's more concise. So if you see something like this, it means that sum equals sum plus I, but it is a more concise way of writing it. Hello everyone, welcome back. We are going to do another coding exercise using for loops. Here we would like to calculate the factorial of number 5. So in order to do that, we can use for loops to calculate the factorial of number 5. So to do that, we initialize the factorial equals 1, and then we right away start with the for loop. So in order to start with the for loop here, we start using the int I equals 1 until 5 because we are considering the factorial of number 5. So if we are considering factorial of number 10, we can put 10, the upper bound, and then it increases one step at a time. Then we enter the loop. When we enter the loop, we calculate the factorial equals factorial times I, or more concisely, we can say factorial times equal I. We could write either this or factorial times I. So either way, there it is going to give us the same result. It depends on you, but it would be nice for you to start making your code more concise as you proceed. So let's see how it works. So it is compiling now. Okay, so here it is. We start with the value 1. So the factorial initially is 1. So 1 times 1, when I enters the loop, its value is also 1. So 1 times 1 equals 1. Then uh, we have the I equals 2. 2 times the previously iterated factorial is 1. So 2 times 1 equals 2. Then factorial is 2. So let me just write it down. I think it would be easier for you to grasp. So I equals 1, it will be like 1 equals 1 times 1. So here you see when the I equals 1, it enters the loop. So the factorial is 1 equals factorial again is 1 times 1. So when I equals 2, it's like factorial again is 1, then factorial again is 1, and then it's 2. So the final result would be 2. So when I equals 3, it's like 2 equals 2 times 3. So 2 times 3 would be the new value, which is 6. So I would say here factorial, yeah, factorial. So let's write the results in this part. It would be, I think, easier to grasp it, so we avoid any mistakes. So in the next round, when I equals 4, we have factorial equals 6 times 4, which is 24. So far we see, yeah. And then the next round, which is the final round, is done, which is 120. And it gets the final result. But if you still think that it is hard to understand this concept, we can keep using it until we get used to it. So the formula would be like factorial equals the current factorial times current I. So because the first factorial is 1, we have 1 here, and the first I is 1, we have the 1 here, and the final value for the factorial in the first iteration equals 1. Then we have the second round. The second round, I equals 2, because I is incremented in the second iteration. So the value of factorial equals 1 because it comes from the previous iteration, and its final result would be 2. In another iteration, I equals 3, then its multiplication with 2 would be 6. So 3, because it's the third iteration, 2 comes from the previous value of the factorial from the previous iteration, and it equals 6. And then I equals 4 in the fourth iteration times 6, which is the value of factorial from previous iteration, and the final factorial would be 24. Let's write the last one as well. So I equals 5, we have factorial equals 24 times 5 equals 120. And when I equals 5 times 24, which is the value of factorial from previous iteration, and the final factorial would be 120. And we don't have I equals 6 because the upper bound for the I is to have I smaller equal 5. And then the loop is finished, and here we are saying the factorial of 5 is, and then we print the actual value of the factorial that we did the operation over here. So this is actually how the logic is behind the for loop. Hello everyone, welcome back. In today's lesson, we are doing another coding exercises using for loops. So another possibility for for loops is to print two things simultaneously. So far we were increasing the value of I from one number to another, but it is possible to decrease its value from one number to a lower number, and we can do things simultaneously. So look at this example. We start with one for loop, and it's a bit longer for loop as you see here because two integers are defined, but it still has its three parts. So in the first part, we mentioned that int I equals 0 and j equals 5. So if you remember previously, I could tell you that we could initialize I equals 1 and we could initialize b equals 2, or we could say int I equals 1, b equals 2, simply like this. So it would be more concise. So here the warning is that because we are not using them, but it is possible, we had this in previous sections, that we could define two integers in one line. So here we are doing the same thing. We are defining the int I equals 0 and j equals 5, but the only important thing is that you don't have to forget this comma to differentiate them. Then a semicolon, meaning that the first part is finished. So upper bound and lower bound here, if we want to put, saying that, okay, we would like to I to be lower than 5 and it's a logical operator, and at the same time j to be greater than 0. So when both conditions, because it's an AND logical operator, when both conditions are met, this part is satisfied. And in the last part, so we then have another semicolon here to differentiate the second part and the third part, and then we have the incremental value of I and decremental value of j. So we are saying that, okay, I has to increase one by one, but j has to decrease one by one. So if everything goes well, we enter the loop finally. We see out I, colon, space, and print value of I, and then we put a comma here in the printing because we want to differentiate the I and j. And then we put j and we print the j. So it's as simple as that. So let's run. Okay, it's compiling. Okay, so let's analyze the code. So the first time that we enter the loop, I equals 0 and j equals 5, as it is printed correctly, because I starts from 0 and j starts from 5. So the first time it enters, it prints the value I and j. Then in the second iteration, I is increased and j is decreased. So I equals 1 now, it is still lower than 5, so it enters, and j is now number 4, and 4 is still greater than 0. Therefore, both conditions are met, and it is important to have both conditions being met as it is an AND logical operator. So we enter the loop again once more, and we have the I equal 1, j equal 4. So this time, this iteration is finished. Then we increase the value of I, we decrease the value of j. So now I is 2 and j is 3. Everything is passed. I is still lower than 5, j is still higher than 0. It enters this for loop again and it prints like I equals 2, j equals 3. It finishes until it continues until I equals 4 and then j equals 1. So it prints these two values, and then when it increases the value of I and decreases the value of j, we have I equal 5 and j equals 0. And having these numbers for I and j, it will not pass for the second part of the loop because I has to be smaller than 5 and j has to be greater than 0, and they are not allowed to be even like I is not allowed to be smaller equal 5 and j is not allowed to be greater equal 0. Therefore, uh, we finish just right there when I is 4 and j is 1. Hello everyone, welcome back. So today we are discussing the same coding exercise, however, with a minor change. So here we learned that if we want to increase and decrease the value of two integers simultaneously, we can use these for loop. However, so far we were increasing the value of I one step at a time, and previously we were decreasing the value of j one step at a time. Here we know that we learned that we can do it like in each iteration, it increases the value of 2 times. So this I plus equals 2 is exactly like the one that we learned before, something like I equals I plus 2. So this is simply this statement, but written in a more concise way here. So here it means that whatever the value of I is, increase it by 2. So if we print it, if we compile it, we will see how it works. Okay, so let's analyze the code. Here we see that the initial value of I equals 0, initial value of j equals 5, and then again the same rules for the second part. I should be lower than 5, j should be higher than 0. However, here I increases 2 times in each iteration and j decreases 1 time in each iteration. So firstly we enter with I equals 0 and j equals 5. Then I is increased 2 times and j is decreased 1 time. So I is 2 now, j is 4 now. So I is still lower than 5, j is still higher than 0. Then we enter again and we print these two values, I equals 2 and j equals 4. And finally, we increase the value one more time. We iterate one more time, and the value increases for I equals 4 and j equals 3. We print this, and then in the next iteration, I increases by 2 values, so the I would be 6, and j decreases by 1 value, so j would be 2. So let me write it down here. I equals 6, j equals 2. So in this case, this part does not pass. Why? J is greater than 0, no doubt about that. But I does not, in fact, I is not lower than 5 because its value is 6 now. And because we have an AND operation here, and operator here, and both of these two conditions must be met. So either of them, if either of them is not met, then we cannot enter this loop. So since I equals 6 is not lower than 5, this condition will not pass and it does not go through. Therefore, the loop is finished when I is 4 and j is 3. So this is how AND operator would work. If it was like OR condition, it would have worked because either of them, if either of them work, it will work. So let's try to see how it works with OR. You see the difference here? Okay. So you see, so first I0 J5, then I2 J4, then I4 J3, and in the next round I6 and J2. Yes, I is not lower than 5 in this case because it is 6 now. But since we are using OR operator, and when we are using OR operator, either this condition should be true or this condition. Since this condition is still true and j equals 2 and 2 is greater than 0, it enters again. And for the next round again, I equals 8, which will not pass the first condition, obviously, but for the second condition, j equals 1, and 1 is still higher than 0, so it still enters, but it does not continue. Why? Because in the next round, I would have been 10 and j would have been 0. In this case, I, when it's 10, 10 is not lower than 5, and 0 is not greater than 0. Therefore, neither of the conditions would have been met. So this is why the next round is not done and the for loop is finished when j equals 1. So the important thing here is that to make sure when we are using AND operator, both sides of AND must be met. However, when we are using the OR operator, either of the side, if it's met, it's okay, we enter the condition. Hello everyone, welcome back. Today we're going to talk about another way to write loops. And here in this lesson, after finishing the for loops in a previous lesson, we're going to focus on while loops or while conditions. So there are different types of loops that we can employ to write certain number of blocks to print certain number of blocks and execute certain number of codes, and one of them was for loops and the other one is while loop. So here the structure of a while loop would be like we say while and then the condition, and then we enter the executive part, and this is a place where we write down our code. So let's start with an example. I think it would be easier to grasp the idea when we make an example. So here previously we used to go through the for loop. So if we want to write a number to write a program that prints us number 1 to 5, we had to write like for loops, something like this. Let me just type it down. Int I equals 1, I equal smaller equal 5, I plus plus, and then we could say okay, print I and L. So this is how we used to print number 1 to 5 previously. However, if we want to do the same thing but using while loop, we can break down these three parts of the for loop into different parts. So first we initialize the integer number named num as to be 1, and then we start the while loop. So we start the while loop, and in the parentheses we only write down one part of the condition, which is as long as num smaller equal 5. So the condition would be something like this. So we repeat the while as long as num is smaller, less than or equal 5. Then we enter the loop. So we print out the num, and here we are incrementing the value of num ourselves. So previously we used to put this part in the parentheses, but we are putting the uh, increment part inside the loop. And previously we used to initialize the integer in the parentheses, and we are initializing it before the loop. And then we are printing the the num using this cout function, and also the second part of the parenthesis for the for loops is exactly printed here. So the reason why we may need to use, for example, while loops to execute our code is because a while loop in C++ is it can help us to repeatedly execute a block of code, like similar to the for loop. However, the while loop is more straightforward and often is used when the number of iteration is not known beforehand. So when we don't know how many iteration do we need, we simply use a while loop and we say as long as the num less than or equal 5, just do this for us, and then change the value of num so we can increase it or decrease it as we want to see in this line. However, if we forget to write this part, it will become like an infinite loop because it is printing, for example, num equals 1, it enters the loop, it prints 1, and then it prints 1, and then it prints 1 forever until we stop the program because 1 is not being increased. So when we increase the value by 1 here, then the next time that it enters the loop, it's 2, then it's 3, etc. So let me just run the program and see how it works. Okay. So yeah. So here num equals 1, and when we want to go through the condition of the while loop, we say, okay, num equals 1. Num is less than or equal 5. Yeah, it passed the conditions. It enters the loop. It prints 1. Then it increased the value of num by 1. So num would be 2. Then it comes here again and checks the condition. 2 less than or equal 5. Yes, enter, print, and then increased. So now it's 3. 3 smaller or equal 5, yes, enter, increase, it will be 4, and then again until it's 5. When it's 5, it enters for the last time, and when we increase the value, it will become 6, and 6 is not less than or equal 5, so therefore it does not enter this loop again, and the program is finished. So this is how while loop would work, and in the next sessions, we are going to do some coding exercises using while loops, so it would be easier for you to see it in different examples and start making it understood for yourself and start coding it yourself. Thanks for watching. Hello everyone, welcome back. Now we're going to do some coding exercises using while loop. We would like to write a program that works like a calculator to adds up whatever we give it as an input, and it's going to work as long as we are adding a new numbers, except if we put 0, it will stop. So for example, I would like to add a few numbers and know the sum of all of these numbers. So I keep entering new numbers, and if I mention if I put 0 as one of the numbers, the program knows that I would like to finish the input numbers, and it returns me the result. So for this program, we need to write a while loop. We cannot write it using for loop because we don't know how many numbers the user would like to give us so that we can do the calculation for him. So as long as the user is giving us any number, we're going to store the number, and when he or she gives us the number 0, we consider it as a sign to that he is done with entering the numbers. So we do the final mathematical addition for him or her and return the person the result. So let's see how it works. I think when we run the code, we can understand it a bit easier. It's easier to understand. So We initialize one number called number, we initialize another integer called sum. We set sum to be 0, and then we tell the user enter numbers to add and 0 to stop. So if the person enters 0, the program is going to be stopped. However, any other number to be entered by the user means that the user would like to add these numbers. So the number is read from the user using cin function. So we write a while loop here. So the while loop would be like this. The condition is like as long as the number is not equal 0. So continue until user enters 0. As long as the user is not entering 0, enter this loop. We enter the loop. We assign the number to sum, store it in the sum, and then we ask again from the user to give us the new number that the person would like to add up to the previous number. So let's try it once. It's easier to grasp the idea. So I mention, okay, enter numbers to add. I say 1, I enter, nothing happens. I say 2, I enter, nothing happens. I say another 2, nothing happens. Now I put 0. So now it's done. When I put 0, it gives me the final sum. So 1 plus 2 plus 2 would be 5. And when I put 0, the program is finished, because here we are mentioning that enter this while as long as number does not equal 0. So when I put 0, it cannot pass this condition, and it simply prints out the sum. And how is it printing the sum? So let me remind you of this. So we learned that this line would be, so what we have in line 181 here equals this line. So instead of writing this, they wrote this. So let me just show you how the program worked in my example. So initially I mentioned the number to be 1, 2, 2. Okay. So initially I said number equals 1. Then I mentioned number equals 2. Then I mentioned number equals 2 again. So it starts with this. So the sum is 0. It says sum equals 0 plus 1. Then sum equals 1 plus 2. Why? Because, so initially the sum equals 0 because we initialize it to be 0. And we enter the number to be 1 in the first round, and 1 plus 0 is 1. So 1 is assigned to sum. So then it goes for the next round. So as for this equation, sum equals 1 from the previous iteration. So the value of sum is 1 here, plus number. So as the second input, I put 2. Then the value would be 3. And then the equation would be 3 because 3 was the final value of sum from previous iteration, and in the new iteration, so the sum is 3 plus I mentioned the another 2, so the sum would be 5. It's exactly how it is computing this sum here. So 1, 2, 2, and then when I put 0, it exits the program. Let's try it once more. So so it's basically working like a calculator. If I say 1, 15, 18, 20 and then 0, it computes everything for us. So 20 plus 15 will be 35, plus 18 and 1 will be 54. So this is how our calculator is working here. When we smash the 0 button, it exit the program. And this is actually one of the usefulness of while loop. So we don't know how many input the user can give us. So it is customized. So one user can use it for 2 times, one user can put it for 10 times, whatever they want. And when they are done, they can put 0. Of course, we could do it using for loops as well. Using for loops, there were some ideas to say that, okay, we are going to ask you a bunch of numbers that you would like to add. Please first tell us how many numbers you want to add initially, be a priori. So that we could do in a for loop as well, but it's much easier to do it using while loop. So this is actually why while loop is there. Thanks for watching. Don't forget to exercise these coding exercises yourself. Hello everyone, welcome back. Welcome to another coding exercise. Today we are going to write a program that counts down a number from 10 until 0 and prints the value one by one as it is decreasing. To do that, we use while loop here in this example. So we initialize countdown integer as to be 10, and then we mention while the countdown is greater than 0, enter this condition, and first print the countdown for us and then reduce its value by 1. So then next round the countdown number will be 9. It prints 9, it reduces the value to 8, then another time 8 is still bigger than 0, it enters the loop and it prints the 8 and then it reduces the value. So let me run and then we analyze the code once together. So here, as you see, it says 10, 9, 8 until 1 and then lift off. So this is how the program works, as you see here. So 10 is the initial value. Is 10 greater than 0? Yes, it enters. It prints 10 here. Then it reduces the value of 10 by 1. So now the countdown equals 9. It comes back here. 9 greater than 0. Yes, enter. Print 9. Reduce the countdown value by another 1 value. Will be 8. So 8 greater than 0. It prints 8. It reduces the value again by 1. It will be 7 now. 7 greater than 0, prints 7 and reduce it by another 1 value. So we continue until it's 1. So 1 greater than 0, see out 1, we print the 1 and we reduce the value of countdown by 1, which will be 0. So 0 greater than 0, no. So it does not pass this condition. It will not go through the while loop anymore. And it says lift off. So this is how while loop would work. So we can increase and decrease the value in the loop. So previously, if you remember, we had 3 conditions for loops. We used to have like for int equals I int I equals 1, I smaller than 10, for example, I plus plus, and in this situation, do something, for example. It is notable to consider this. So this int I part is written here, for example. This second part condition is written in parentheses for the while loop, and this last part, the incremental part or decremental part, is written within and inside the while loop. So this is the only thing that we need to be careful about. Otherwise, it's very straightforward and it's good for you to start practicing and coding hands-on programming so you can get to know these little things and these little steps to make errors and learn from your errors. Thanks for watching. Hello. So today we are going to discuss another way to write loops. It is do while. So it is very similar to while loops, but there are certain differences. So a do while loop in C++ is similar to a while loop, but with one crucial difference. A do while loop will execute the block of code at least once, even if the condition is false, on the first check. So this is because the condition is checked after the code has run and not before. So the main advantage of a do while loop is that it ensures the code block runs at least once, no matter what. So this can be useful when we want to ensure the user interacts with your program, or when you need a certain action to take place at least once before checking a condition. So it's often used in programs that require user input because you typically want to prompt the user at least once before deciding if you need to loop again or not. So this is basically how it works, and generally we start the structure would be, we say do, and in the brackets we execute the code, and we say while, and then we put the condition. So let's see an example here. So we initialize one integer called number, and then we say do, we open the bracket, we say enter a positive number. We store the positive number that the user enters, and we check. So if the number is lower or equal 0, or we say that's not a positive number, please try again. And then it comes here. So the condition is that if the number is lower or equal than 0, lower than or equal 0. So it repeats until the time the user gives a positive number. So to say it in an easy way, it would be like this. It asks me to give a positive number. So if I enter a positive number, the loop will finish, and then it prints out this line saying that thank you, you entered, and enter and print whatever we entered. Or if I give it a negative number, it enters this if condition. For example, I would say -2. So if I say -2, it is for sure lower than 0. It says, okay, that's not a positive number, try again. And while the number is -2, go back to this part again, enter a positive number, and then we store the number, and then it sees if it's positive or negative. It is, if it is negative, it repeats everything again. So let's try and see how it works. So enter a positive number. I would say -20. That's not a positive number. Please try again. So -25. Enter again. It says that's not a positive number. Please try again and enter a positive number. -30. It will not finish as long as I'm giving a negative number. And when I say like 20, it says thank you, you entered 20. So this is how generally a do while situation, a do while loop would work. So I entered 20, it stored, I firstly entered -20, it stored -20. -20 is lower than 0, yes, so it prints this value and it says, okay, while -20 is lower than 0, go back to the do. So it starts from here again, enter a positive number. And we entered -25 here. It says -25 lower than 0. Okay, it showed this message and saying that okay, 25 is lower than 0, go back to the top. So it goes back and to the top again and again and again until I enter a positive number, which is the case here. And then it says thank you, you entered 20. So this is basically how a do while loop would work. it it is being executed first, as we mentioned. Then the condition will be checked to see if another execution of code is required or not. So if I was going to oops, sorry, what did I do? Yeah, so if I was going to enter like a positive number in the initial iteration, like if I say enter a positive number, and if I say 11, it says thank you, you entered 11. So I say enter a positive number, it says okay, the number is 11. Number is 11 is not lower than 0, then it escapes. It's not lower than 0 again, it escapes. So the loop is not going to be executed anymore, and it says thank you, you entered like 11. So it is one time executed, and then the condition is checked here. So this is the main difference. Hello and welcome back. Today we are going to give you a coding exercise using do-while loop, so you see how practical this do-while loop is. So we are going to write a program that checks to see if you're entering your password correctly or not. As long as you're not entering your password correctly, it is going to ask you enter the password again and again, and until it is correct. So when you enter the correct password, it finishes the program. So initially we initialize two strings, one password and one corrected password. So imagine that the correct password is ABC, something very easy. And we start our loop here, do, so it enters the loop without checking any conditions. It says enter the password, and you enter your password. It says if the password is correct, it does not enter this condition, because this condition says that password does not equal the correct password. So if the entered password, the one that you enter, is not equal to the correct password, that is ABC, it says enter incorrect password, try again. And it says as long as the entered password does not equal the correct password, ask this again from the user. And if by chance you mention that, okay, enter the password, and you enter the password and the password equals correct password, it does not enter this if, it escapes, and here the condition does not pass because the password equals the correct password, so it does not have to go another time in the loop, and it says access granted. So let's try and see. So if I say ABC, it says access granted. So here is my password. Here is the correct password, ABC. Enter the password. I say ABC. So ABC, it says that password does not equal correct password, but this is not our case because the entered password and the correct password are the same. So it escapes this loop. Then it checks to see as long as password does not equal the correct password. So this is not also our case because they are equal. Therefore, it finishes the loop and it gives us the access. However, let's try once more, and it says like enter the password. I would say something like this. It says incorrect password, try again. I would say anything, try again, try again. And whatever you enter, it says try again. And in the end, I mentioned the correct password, and it says, okay, access granted. So you see, this is very useful example, and this is a very practical example. In the real world, we have some access like that in the world when we want to check something like emails, etc. Of course, there is a limit until like you can repeat it for 2 times, 3 times. After that, your account will be blocked for security reasons. However, we can use the do while to do that. So here it says enter the password. I say QWE. It says they are not equal. Therefore, it enters this if and prints incorrect password. And because they are not equal, like the entered password and the correct password are not equal, it goes to the loop once more. It says enter the password and it stores, and I said TRTY, they're not equal. It says incorrect password, try again. So it is what it is printed here. And then because they're not equal, it goes again to the loop. So this continues until I give the correct password in the end, and it says access granted. Hello everyone, welcome back. Now we're going to do another coding exercises using do while loops. So here we would like to write a program that asks a user saying that would you like to play the game or not? So if you want to play the game, it will go through the loop again and again. Just imagine when it goes through the loop, it means that the user is simply playing the game one more time. And if the user says no, it finishes the loop and it gets out of the loop and the program is exited and everything is finished. To do that, we define a character called play again here, initialize as a char, and then we have a do while situation. So do, and we open the bracket, we say you played the game. So already, for example, just imagine already the user is in the game and the game is finished now, and this message is shown to the user. So you played the game. Do you want to play again? Y or N has to be yes or no. And whatever the user says, it is stored in the play again character using cin function. So if the user says lowercase y, case y or uppercase y, means that the user would like to play the game one more time. So imagine when the user says yes, the program will do another round of playing and then it shows you played the game. So do you want to play again? The user says yes. So the user says yes, play one more time, and then it says you played the game. And if the user says no, it breaks the loop and everything is done, everything is finished, and it see out saying that thank you for playing, goodbye. So, and then imagine that it exits the game, exit the game. So, why we are having but this condition here? So, in order to consider this condition here, we have a play again character, and we have an or operator, logical operator. So, because C++ is sensitive to get the result as y or y, they are perceived to be two different things. We mention if the written answer from the user is either of lowercase or the uppercase. So because in the or logical operator, we know that either of the side of the condition must be true. So if this is true or this is true, then it repeats the loop again. So if the user says y in lowercase or uppercase, it knows that the user wants to play one more time. But however, if we didn't have this part, okay, let's imagine that we didn't have this part and we only have this part of the condition, this play again with lowercase y, and if the user answers with an uppercase y, it does not know it does not recognize y because only lowercase y was initially defined to in this condition. So it is important to consider both cases so we make sure we're not missing anything. So let's run the code and then we analyze the code again. So it says, do you want to play again? I would say yes. Do you want to play again? This time uppercase, yes. And yes, lowercase y, yes. And do you want to play again? I would say no. So thanks for playing, goodbye. So it, as we explained, do you want to play again? I would say y. I would say yes, showing y. And then it says, okay, the guy said why, let's do the loop again. And it asks me again, do you want to play again? I would say yes, another round. And then if I say yes, another round and another round, etc. And if I say no, because this condition is not passed, this while condition is not passed, then it gets out of the loop and it says, thanks for playing, goodbye. So you see that there are some practical examples for do while, and they are pretty common everywhere. When I make these examples, you can see that everywhere you're in every day, on a daily basis, you face these situations that are using these do whiles or for loops to fix some problem and provide some services to their customers. So please practice all of these things one by one and try to do the coding yourself, try to make the error and try to understand where the problem comes from. So from errors is where you can learn how to do the coding. Just stay tuned, and in the next lessons we're going to go through another type of loops. Hello everyone, welcome back. In today's lesson, we are going to talk about nested loop. So a nested loop is simply a loop inside another loop. This means that you have one loop running within the body of another loop. So the outer loop runs a specific number of times, and for each iteration of the outer loop, the inner loop runs completely. So imagine a clock. So the hour hand is like the outer loop and the minute hand is like the inner loop. So for every movement of the hour hands, which is the outer loop, the minute hand inner loop completes a full cycle. So another way to visualize this is to think about a grid of rows and columns. So the outer loop iterates through the rows and the inner loop iterates through the columns. So in order to make it more clear, let's come up with an example. So here, just imagine that we would like to write a program that generates a 5 to 5 multiplication table. So we have rows and columns here, and we want to see this in the output. How to see this in the output? Previously, we learned about how to do for loop, but when we were doing for loop, it was like 1, 2, 3, 4, 5. So, and that's it, or 1, 2, 3, 4, 5. So it was not like a full table. So I would like to write a program that generates a 5 to 5 multiplication table and shows something like this. To do that, the outer loop is defined like int I equals 1, I smaller than or equal 5, and I plus plus, and then we enter the loop here. And then we have the the inner loop, we have the int j equals 1, j lower than or equal 5, and j plus plus. And then we see out I times j. So let's run first the program. So exactly as we want it. So exactly as we want it. We have like 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. But how does it work? So let's analyze the code a bit so we can understand how it works. So here we enter the loop with I equals 1, then j equals 1. So when I equals 1 and j equals 1, I times j would be 1. Then still here we had the I equals 1, j equals 1. So and it's finished now. We did the calculation and we printed 1 here like this, and we also put it here. Then j is increased by 1 value while the I stays the same, because we didn't finish this loop first to go back and increment the value of I. So I stays the same, and then j increases. So the first result was I times j equals 1. Okay, so now I still equals 1 while j equals 2. Now I times j equals 2. Another round. I still equals 1 and j increases until it reaches, 5. I equals 1, j equals 3. Then we have I times j equals 3. And this continues until we have I equals 1 and j equals 5. Therefore, I times j equals 5. So when we reach this stage, it's the first line being printed. Yeah. So it means that this j started from 1 and reached to 5. Okay, so it reached to 5. Now it has to get out of this inner loop. When it gets out of this inner loop, we print out cout and del. So it is here now when the j loop finishes, and it goes to the next line here. And when it goes to the next line here, please note that it is in the first loop still. It goes up. So now the value of I increased from 1 to 2. So now we have I equals 2, j equals 1 again, and I times j equals 2 as to have here, as we have it like here. So, and then I stays 2 until j is 1, 2, 3, 4, 5, and when j reaches 5, it again finishes the inner loop and it goes to the next line using this end-l function. It is here, it goes to the next line, which will be here. So now I is incremented from 2 to 3. So then it does the calculation again. So this is basically how inner loops would work, and it's a very nice way to make when we have two-dimensional arrays, lists, numbers, etc. We can use nested loops, and they are very convenient to work with, and they are very practical. So I would suggest you to practice this nested loop example as much as you can. So, and you start, if you forget what I told you about the analyzing this part, it would be nice to go back and review these analyzes and then start doing the coding yourself. And then when you forgot, you either can come back to this video or you can start doing the analyzes yourself to understand the logic behind it. It would be very important, I guess. And then move on to the next coding exercises. Thank you for watching. Hello everyone, welcome back. Today we are going to do another coding exercise here. So we would like to write a program that prints a pattern of numbers in the form below. So this is the form that we would like to print. So in order to print something like this, we usually don't know it by heart. We need to think about it. So this is where the programs get a bit more complex than before, and we need to start thinking about how to get to the result that we want a priori to start just right away coding the program. So in order to print that, we can use a nested loop. To do that, we have one outer loop and one inner loop. So in order to have these two loops, we first start with the outer loop, that is I. We say, so let me first run the program so we see that we have the result and then we analyze it. Okay. So here we have the result as we wanted. So, but how did we get there? And with only 3 lines of code. So how did we get there? Let's analyze the code. So first we have the outer loop. which says integer I equals 1, I lower than or equal 5, I plus plus. Then, so this is not something very strange. This we have. This we already had in many examples. So here we also have this for int j equals 1. However, the upper bound of j is I. So j must be lower than or equal I, and then we increment its value one step at a time. And then we print the value j. When the first loop, the inner loop is finished, we go to next line, and then we go to the outer loop again. So how does it work? Let's see. Let's start writing the output here step by step. It would be easier to understand the logic. So first I equals 1, we enter the loop. J equals 1, and at the same time, j must be lower than equal I. So, and I is 1, so j must be lower equal 1. So only one iteration for j is allowed because it already starts from 1 and it must be lower than or equal to 1. So when it enters I equal 1, j equal 1, and the result would be 1. So it prints the value of 1 like this because we are having C out j. Then it goes here, so the inner loop is finished. It goes here, it goes to the next line. This is where the first one is printed, and then it's go to the next line. Now I equals 2. I equals 2, j again equals 1 because it starts from 1 every time. And j must be lower than or equal to I, which will be something like this. So j will be lower than or equal to because the value of I is 2 this time. So given this, we will first start with j1. So with j1, the inner loop is executed, so it prints 1. So the first result will be 1. And then it goes to the inner loop again. It increments the value of j, and j will become 2. 2 is still lower than or equal to as the condition here, so it enters the loop again and prints the value 2. So it prints 2. When it prints 2, it reached its maximum level, so it reached its upper bound, which is equal to I. So I is 2 and it reached 2, so it's finished. So the inner loop is finished. It prints it does one handle, so it goes to the next line here and starts from here. So now it goes to the first outer loop. So now I equals 3 and j starts from 1 again, and as j has to be lower than or equal to I, it means that j must be lower than or equal to 3. So j starts from 1, 1 enters the inner loop, and we print 1. Then we increment the value of j. J is 2 now. 2 is lower than or equal to 3. So yes, it comes here again and prints the value 2. And another time j is increased, and then now the value of j is 3. 3 is passing this condition, so 3 lower than or equal to 3, yes, so it comes here again and prints the value of j. So now that j is 3, it reached like this, like it's like writing 3 lower than equal to 3. So it does not, it's not able to go another round, because if it goes for j equals 4, it does not pass this condition here. So because of that, the inner loop is finished. It goes to the next line using this part of the code. So, and it goes to this part. So as you see here, this one here, we reached here. Then we have this one, which is here. Then we have 1, 2, 3, which is here. And then next time when the inner loop is done, it comes here, it goes to the next line. We were here, it goes to the next line. So now we are here with this line, and then it has the outer loop. So it goes back up again. So I was 3, we increase the value of 3, it will be 4 now. 4 is lower than or equal than 5. Yes, pass the condition, enters here. So enters the inner loop. So I equals 4, j equals 1. So j must be lower than or equal to I, because in the second part of the for loop, this condition applies. And then it means that because I equals 4, it means that j must be lower than or equal to 4. To do that, j equals 1 starts the loop while I is 4. So it's like writing 4 here for this time, for this round of iteration only. So j equals 1, it prints 1, and then it comes back to this line. Okay, it increased the value of j, and then prints 2, then comes back to this line, increase the value of j, print 3, and then 4. When it reaches 4, it means that j is equal to its upper bound, then it cannot continue. So that it cannot continue, it finishes the inner loop, and by having this line, it we are now here. After this line, it goes to the next line, and then we have the outer loop. So the outer loop is still I, which is 4. Now we increase the value of I from 4 to 5, which is the last time, because I also must be lower than or equal to 5. So this is the last round that we enter. So we enter with I value 5, I equals 5, while j equals 1. And it starts from the j equals 1 again. So j has to be lower than or equal to I, means that j has to be lower than or equal to 5. So it enters with j equals 1. So it prints 1 time, and then increase the value of j, come back here, it prints the value 2, 3, 4, and finally 5. And it cannot go beyond 5, because when j is 5, it is reaching its maximum level, which is 5, and then it goes to the next line. So from there we go to the next line, but we do not go back to the outer loop anymore, because also when the value of I is 5, we increase it to 6. It does not pass this condition, so it cannot enter the loop again. So this is how this nested loop would work. So let's run one more time. Yes, so you see how this nested loop has worked, and how we got to the printed form and pattern of the numbers that we were looking for here. It is very important to start practicing these things yourself, because it's little by little it is getting a bit more complex. So in order to make sure that you are improving your coding skills as you're proceeding through the course, please try these practices yourself several times. This is very important. Thank you for watching. Hello everyone, welcome back to another lesson. In today's lesson, we are going to do another coding exercises using nested loops. However, before we dive in, if you haven't had the chance to rate this course yet, I kindly encourage you to take a moment to do so. So your feedback is incredibly valuable in helping us improve and ensure the future learners have the best possible experience. So thank you for sharing your thoughts and rating this course. So now let's move on to our next coding exercise. Here we would like to write a program that prints a 4 times 6 a rectangular of asterisks. So what we would like to be printed would be something like this. So we have 4 rows and we have 6 columns here. We would like to print that and we need to use a nested loop to do so. So the outer loop would have four uh four range, like I starts from 1 and we'll go up until 4 because we would like to have 4 rows here, and as the statement mentions, and then as we would like to have 6 columns, we are having the inner loop to range from 1 to 6. So we start from here. Let's run the code first and see how it works, and then we will start analyzing the code. Okay, so now we see that we have 4 rows and 6 columns. So let's analyze the code. So initially here I equals 1, enter the loop. So it checks to see if I equals 1 and it's lower than 4, I plus plus. So I equals 1, enter the outer loop. And when we enter the inner loop, so j is equal to 1. So I would say I equal 1, j equal 1. Then when j equals 1 in the first round, it says print 1 asterisk. So it prints 1 asterisk. Then the inner loop is finished one time and it goes back again. So it increased the value of j from 1 to 2, and it comes back here and it prints 1 asterisk for us. Then j j was 2. Now we increase the value of j by another value, and j becomes a 3. Then 1 asterisk is also printed here. It continues until j equals 6, and we print another asterisk here. So it would be like 6 asterisks would be printed, because when j equals 1, it prints 1, then it's 2, another asterisk, then j is 3, another asterisk, then j is 4, 5, and 6, another asterisk. So the range of the j will, depending on the range of the j, we are going to print asterisks here. So we have the value of from 1, j equals to 1, and j lower than or equals to 6. So 1, 2, 3, 4, 5, 6, we are going to have 6 asterisks being printed, because this is how the range tells us. So when j reaches its upper bound, the inner loop is finished. When the inner loop is finished, we finish this column. We have the endl syntax here. So like it's like here, we printed 6 asterisks. Now we are here, we have one endl, which will force the program to go to the next line here. So when we go to the next line, we go back to the outer loop where I was 1 initially. Now we increase the value of I by 1 and I becomes 2. I equals 2, and j starts from 1 to 6. And because of that, we will have another 6 asterisks being printed, because when j equals 1, it enters the loop, print 1 asterisk, then j is increased to the value of 2, then another asterisk is printed here until j reaches its maximum level. So then when j reaches 6 again, we finish the inner loop and we go to the next line. We are here. When the second inner loop is finished, we go until here because of end L, and we have the outer loop. So in the outer loop, I now equals to 3, and the same logic goes for I equals 4. So basically, if you would like to have like 4 rows, we have the upper bound, we have the range of I from 1 to 4. And if we would like to have 6 columns, we need to have the j or the inner loop has to be from 1 to 6. If we would like to have 8 columns, we can simply say j starts from 1 and it's going to be lower than or equal 8, for example. So this way we are going to have 8 columns here. So let's try and see how it works. Let's see. Yeah, so here as you see, 1 2 3 4 5 6 7 8. So we have 8 columns here now because we mentioned we would like it to go up until 8. And if we would like to have, for example, only 2 rows, we can change the range of I and say it starts from 1 and it's going to go up until 2. So let's compile again. So yeah, here we see that now we are having only 2 columns. So depending on what we would like to have as columns and as number of columns and rows, we can change these numbers. And also now we are printing asterisks. So we can print whatever we want. For example, we can print addition. So let's try this one. We can print additions, or we can simply print we can simply print uh, I times j, or whatever that we want. So it depends on what we would like to print. So now it's going to give us the value of I times j every time. So there is a, oh, sorry, I need to put this sign here. I forgot. Okay. So when we compile now, okay. So here we see that it is printing the values of I times j. Like for example, I equals 1 and j equals 1, so it prints 1. Then I is still 1, but j is now 2 because the value of j is increasing from 1 to 8 now. So then 2 times 1, here we have it, then 3 times 1 we have it, then 4 times 1, etc. Then we finish the inner loop, the first inner loop, and we go for the second loop. So we go for the incremented value of the I, which is the second iteration of the outer loop. So I equals 2, now we have I equals 2, and when I equals 2, j equals 1, we have 2. When I equals 2, j equals 2, we have 4. When I equals 2, j equals 3, we have 6, etc. until we reach the I equals 2, j equals 8, which the result will be 16. So if we would like to have like now 4 columns, we can also try this like that. So here, if you would like to have like 4 columns, we see that the 4 columns is shown like, sorry, 4 rows. So 4 rows are added. So I equals 4 here, j equals 1. So the result would be 4 until it gets here to the last number where it is you see the last row means that the last iteration of the outer loop, so I would be equal to 4, and it is the last column, so columns are not very organized, but this is the last column, so it means that the j also equals its largest value, which is 8. So 8 times 4 would be 32. So in order to have a matrix, for example, of numbers, we know that we can use nested loops, and also the number of rows depend on the outer loop and the number of columns depends on the inner loop. Hello everyone, welcome back to another coding exercise session. Today we are going to write a program that prints a grid of numbers where each row contains the numbers from 1 to 4. So we are going to have 3 rows and each row needs to have numbers from 1 to 4. From the previous lesson, we learned that if we are going to print a matrix, we need to use nested loops. And the outer loop can show us the number of rows, can bring us depends on the number of rows, and the inner loop depends on the number of columns. So with that in mind, if we would like to print something like this, we have 3 rows, so the outer loop should start from 1 to 3 and the inner loop should start from 1 to 4 because we would like to have four uh, only 4 columns. So let's run the program first. Okay, we see that what is printed here, it's exactly what we wanted. So let's analyze the code and see how it works. So in order to see how it works, we see that I is equal in the first round, I equals 1, while j varies between 1, 2, 3, and 4. So when I equals 1, it enters the outer loop and it reaches to the inner loop. So j equals 1, it enters the loop, so it prints 1. Then it goes up. We increase the value of j, and j is 2 now, so it prints 2, and also we are printing one space here. So j goes back up again, it is increased by another value, so j is 3 now, so j is printed here, now 3 is printed, and then one space here. So we see that the result would be something like this. Exactly, the first row is created. When j reaches its maximum level, which is 4, the inner loop is finished, and we are going to the next line using end L. So we are here. When we have the end L, it goes here. So now I equals 2. So now I equals 2, while still j varies between 1 to 4. And again, the same procedure will continue. So j equals 1 enters, it prints j and 1 space. Then j is increased here by 1 value, it enters, it prints j with 1 space. Then we increase the value of j another time. Now j is 3, so we print j here, which is 3 with 1 space. And another time j is 4 now. This is its maximum level upper bound. And we increase the value of j from 3 to 4 by 1 value, and we print j, and the inner loop is again finished, and we have endl. So we're here. After endl, we go to the next line, and then we increase the value of I to 3. Again, the same thing will happen. So if we would like to have 3 rows, we are ranging I from 1 to 3, and if we would like to have 4 columns, we are ranging j from 1 to 4. However, if we would like to have like more columns with more numbers, like if we would like to have something like this, we can simply increase the range from 4 to 5 and see its impact. Let's see. Okay, so we see that now we are having 3 rows and 5 columns. So depending on the number of rows and columns that we would like to have in the output, we are going to modify the outer loop range and the inner loop range. Thanks for watching. Don't forget to practice all of these exercises several times so you get used to coding nested loops.